Good afternoon, everyone. How are you today?
Afternoon.
Hi, Perry. Hi, Noel and Kelvin. Okay, so we continue our lecture this afternoon on the Inter-VLAN, chapter 3, right? It's module 4, Inter-VLAN routing. So yesterday we looked at legacy configuration using the router, okay? And okay, Farah. And also just a recap, Um, the problem with that is that we need to have a lot of interfaces on the router, and router usually when it's sold, it's basically only having a few, minimum two, and then you add on, right? But still, the ability to add on ports or interface to the router does not necessarily solve our problems, right? Because we want to be able to create as many VLAN, right, that we can, since the whole point of having segmented network is allowing, is basically to solve those broadcast domains, right, to make the lines more efficient, but at the same time still allow them to talk to each other. So without the interfaces on the router, okay, then we can do that with the legacy method. So after that, we look at the router on a stick. Okay, basically we allow the connectivity between the switch and the router to be a trunk link. So trunk link means we can then forward or transfer, right, different VLAN frames. Okay, so in that case means we can create as many VLANs as we want. The only thing that we need to do similarly at the router interface is just to create sub interface. Now, sub interfaces are created um, in the software of the router, right? And we note that yes, this solved the problem for the legacy configuration, right? But still, it's limited to 50, okay, 50 VLANs. Yeah. So maybe for small and medium-sized organization, this is okay, right? Okay. But then if you need more and you still want a capability of VLAN, then you have to look at the SVI or the multi-layer switch or layer 3 switch. Okay, layer 3 switch. And that's actually a special kind of switch, right? Because usually switches work on layer 2, right? But this layer 3 switch, by the name itself, it works on layer 3. It needs to be because it needs to take on the functionality of a router, right? So saying that, let me just share my screen.
Got record.
Yeah, I'll record. Right. So this is the third technique, yeah, for larger size network, right? If you want more than 50 VLANs, then this is a better way, right? Inter-VLAN using layer 3 switch. So please note the graphic or the icon, okay, that represents um, the layer 3 switch, yeah? Okay, so you can identify when you see this type of icon. From now on, please identify that that is a layer 3 or multi-layer switch. Okay, so when you see this, know that in that scenario, we're probably going to talk about this multi-layer switch in terms of inter-VLAN routing. Okay, all right. So this is the current way. Okay, current way that people do routing between VLANs is basically to get this this layer 3 switch, and this is basically what Cisco encourage, right? If you note, I'm not sure whether you remember, if you note in the earlier course, right, when we talk about the LAN and the hierarchical um, organization of the LAN, okay, that Cisco is promoting. Uh, a way to create this hierarchical line is to have this multi-layer switch. That means you have segmentation inside your LAN, right? But you still need router. Okay, your router, but then your router, physical router, will basically connect your local area networks, plural, yeah, with the outside, the ISP, the internet. Whereas within your large network, when you want to have your own segmented network inside your large network, right, instead of using routers, you can use a layer 3 switch. Okay, when you start to use router, right, then you're limiting your VLANs to 50 if you're using router on a stick. Okay, the legacy one, nobody use that anymore because that's really limiting, and it costs you you know more expensive because you need to buy modules to provide interface on your router. All right. So how does the layer 3 switch provide this feature, this routing feature? Well, it has this something called switch virtual interfaces. Now, if that sounds familiar, it's quite similar to the management interface. Okay, because the idea is the same. Management interface basically is to allow remote management. But in order to allow that, that means remote management means you can access that switch, okay, to manage it via the network, which means you need to be able to access it using IP address, right? So the management um, VLAN basically, and also the management IP address allows the switch to have this IP address that you can connect to, right? So routing works on layer 3 as well. That's why we have routers as a layer 3 device, right? So it works on IP addresses. So that's why, in order to provide this inter-VLAN routing, a layer 3 switch will also need this switch virtual interfaces, right? So the switch virtual interfaces can be configured, right, to basically tag which VLAN a particular interface, SVI interface belongs to, and also you can, because it's an interface, you can, or you need to provide the IP address that belongs to the VLAN's network address, right? So here's an example. You have this layer 3 switch, okay, and the interface that this normal layer 2 switch connects to is the SVI interface, right? So since it comes from the VLAN 10, so you allow VLAN 10 for the interface, and you provide that IP address belonging to that network address of that VLAN. So VLAN 10 here with this network IP address, but you know that that's the network address. Okay. Whereas on the right hand side is a different VLAN, VLAN 20 with a different network address. Therefore, the interface has a different IP address. So VLAN 10 data or network traffic can now traverse. Okay, will be forwarded. Okay, it comes in here and then will be forwarded to the other LAN. So we achieve what typically we need a router in the middle here uh, to work for us. Okay, we achieve the same thing. All right, all right. So you can see here it says that inter-VLAN SVIs are created. That means uh, physically, if you want to create, you can configure it. You create the inter-VLAN SVI same as when you create the management VLAN interface. So that means configuring them the very similar, right? So SVI is created for a VLAN that exists on the switch. So that means you configure VLANs first, of course, right? Once you configure the VLAN, then you can configure the SVI because you need to assign the VLAN to that particular SVI switch virtual interface, right? So virtual simply means it's implemented in software, right? Okay, so that means your switching, the switching and also the routing, all right? Okay, is done via this SVI. Okay, that means the ingress, the egress goes through the SVI, right? And then inside the switch, okay, same functionality, okay, that is provided by router, okay, to check the routing table and all this thing is also provided. The technique is the same, all right? Okay, so the only difference is that this actually is multi-layer, so it works both because it's a switch. It works on the layer 2 as well as layer 3. Okay, for router, it works definitely should be work on only on layer 3. Okay, so for the router and the switch on the stick, right? It's basically using a virtual interface, like what we have discovered earlier. But it will be able to look at layer 3 packets. So because the this SVI on the layer 3 switch also will be able to deal with packets. This is layer 3, right? So you can see here it says provides layer 3 processing for packets, right? So that means it will, what it mean by processing means it will open up, check the exactly what functionality you can find in the router, checks the header, okay, for the packet, extract the destination IP address, perform the ending on it, just like what the router will do to extract the network address, check the routing table, okay, which but of course when you check the routing table now, your mapping is between the network address and the SVI interface, not the physical interface, right? So what are the advantage? Advantage is that they are much faster than router and stick, right? So because although SVI is a virtual interface, uh, the it's a hardware switch and routing is hardware based, right? Whereas the router on the stick, everything is becomes software based. There is no need for external links from the switch to the router because now we don't need a router to do the routing. Okay, the switching and the routing is done inside the switch itself. Right now, here is this topic is going to be covered in the forthcoming chapters. Yeah, right. The layer 2 Ether channels. Basically, Ether channels. Think of it like how we improve the Wi-Fi. All right, make it faster. We basically have maybe two cables or two or more cables connecting basically two devices, not we're not considering the host, yeah, talking about the switches, yeah. We might connect the two switches using more than one cable. So when we do that, we can basically combine them. So we balance the load of transferring data, okay, between the two switches. We call them the ether channels, right? So when you do that, then you increase bandwidth in terms of because they work together. Okay. So logically, even though physically there may be, let's say, two or three cables, but logically they look like they are one cable, right? So if each cable is about 100, and let's say fast Ethernet 100 megabits per second, suddenly when you have three cable, then your bandwidth becomes between the two switches, become 300 megabits per second, right? So that means we can take advantage of this, right? So you can see that they are not limited to one link because layer 2 Ether channels can be used as strong links right, between switches to increase bandwidth. Okay, so trunking can work with one cable, or if you combine the cables together, become ether channels, you can specify all three to be trunk links, and they are ether channels, so they share the load. Okay, right. So the next latency is much lower because data does not need to leave the switch in order to be routed to a different network. Okay, so when you talk about latency, is when you talk about bandwidth, right? Talk about bandwidth, but we never get to the theoretical limit of the bandwidth because of this latency. Latency is introduced by the devices linking all our. I mean, we have latency on the medium itself, like cable, Wi-Fi, or whatever. There's a latency there, but the latency also introduced by intermediate devices when they are doing the switching, routing, all this, right? They they add, okay, latency to it. Latency simply means here uh, the 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 part of the time that's taken to transfer the data from one host to another host. Okay, so uh, the more intermediate devices you have in between the two hosts, the more latency will be introduced into the network. So that means if we don't need to transfer the traffic to another, like say router lah, kan? Router is another, uh, you know, another device, intermediate device. So by removing the router from the network, then you decrease latency in the case that there's no delay, further delay uh, being being sending to the router and the router doing the routing. So here we use switch. The switch can do the switching. It can also do the routing. So latency is much lower, right? So we can. Here is an example. Of course, not only campus, but when you talk about campus, you sort of know the size of the network, right? So probably the Sabah campus is considered as small, right, in terms of the network requirement. So it's more apt to like a place like UMS or KL Main campus where they have larger grounds and larger grounds to cover more networks, right, and more requirements for hosts. Okay, you can imagine our students maybe probably not even reach 1,000, but in main campus you easily can reach more than 10,000, 15,000, 16,000. So you can see if they are all in the campus, they're all connecting as hosts, right? So you can see the the requirements for that kind of network, right? So this inter-VLAN routing using layer 3 switch is more, you can find it more in the kind of size of a network like you can find in a campus, right? So you don't deploy routers, you instead deploy layer 3 switch. It's more efficient, it's cheaper, it's cheaper, uh, it's cheaper in terms of budget. So layer 3 switch is more expensive than layer 2 switch, but layer 3 switch is cheaper than normally than a router, full router. Okay, right? So you can see there, here it says more expensive. So it's more expensive as compared to a normal switch lah. Of course, because it provides multi-layer functionality, both layer 2 and layer 3, right? So those are the advantage. Now, let's have a look at the configuration for router on the stick. Yeah. So this is the second method. Second method for routing traffic between virtual LANs. Right. So let's look at this scenario. Now, let's understand this topology. We have two switches, S1 and S2, right? And we have two VLANs as well, VLAN 10 here. Okay, this PC1 belongs to VLAN 10, and this PC2 belongs to VLAN 20. Right? And then this is router on a stick, not layer 3 switch. Later we'll see that scenario. This one is router on a stick scenario. So the router on the stick is this router on a stick. This considered as a stick, although you know that it's just Ethernet cable connection, right? So we already know that when we have more than one VLAN, that means we have, let's say here in this case, VLAN 10 and 20, right? So this port, access port will be configured as VLAN 20 port. This access port, because it's host access the network here, right, is configured as VLAN 10 port, right? So only VLAN 10 will be allowed here, VLAN 20 allowed here. So automatically this PC2 will belong to VLAN 20, PC1 belong to VLAN 10. Now we know that between the switches, we need to allow VLAN 20 to traverse. Okay, so of course, in this example, it's very simple. Only show two hosts. So you might say, hey, but why do we need to pass VLAN 20 if there's no VLAN 20? Just this is simplification. Of course, in this scenario, we can always expand PC3, PC4, PC5. One of them maybe VLAN 20, one of them maybe VLAN 10. So whatever it is, we need VLAN 10 and VLAN 20 frames to be able to pass through this link. So therefore, we need to create trunk links. So this switch port mode trunk, right? Switch port mode trunk here. So this one trunk link. So the idea is if you ever want to pass more than one VLAN, so here VLAN 10, VLAN 20, then you create a trunk. So between these two switches, this become trunk link, right? Now,
But do we still need to allow the VLAN, the native VLAN to pass also?
yes. The thing is, a native VLAN by default it will be VLAN 1, right? So if you want to stick with the VLAN 1 as management, then just leave it as management VLAN. Normally we create another VLAN using whichever VLAN number, right? The most popular example will be 99, and we put that as VLAN, native VLAN. We need to, because you never know that you might have a device that's connecting to your network that is may, and also services. That means content or data content that is belong to that needs to travel without being tagged, right? So any frames that cannot be tagged then cannot be identified as belonging to particular VLAN, right? So they need to use the native VLAN. So the native keyword there just to indicate that it's not belong to and it cannot be tagged to any of the VLANs you create, right? So VLAN 10, VLAN 20, VLAN 30, all data VLANs that those frames belonging to that VLAN can be tagged, right? Remember that we can tag it in the frame header. But what about frames that cannot be tagged? That cannot be used with VLAN 10, 20, 30. So they still need to be transferred. So they will make use of native VLAN. So you do need to configure it, right? Now, if you're asking in terms of answering question, it depends on the question. If the question asks you to configure native VLAN, then you do it. Okay, but it doesn't hurt to configure extra, right? They don't minus mark. We don't normally when we're marking, we don't minus mark just because you add on extra, okay, extra answers. So even though maybe let's say the question didn't ask for native VLAN, but you put in and it's an addition to the correct answer, you already got your answer correct, but you got another answer which is native even though it's not part of the answer because maybe lah, right? Because the question didn't ask, but we don't mark down. That means we don't minus marks, right? But in the real world, usually you will do that, lah. You will configure native VLAN just in case. This is very hard. If you don't configure it uh, at the beginning, sooner or later you'll find that some traffic cannot pass through, and very hard for you to diagnose later on. Okay, oh, why it doesn't pass through? And then you realize, oh, because this one cannot tag the frame, then there's no native VLAN, so that means they cannot pass through, right? If you don't have native VLAN, then frames that cannot be tagged cannot pass through here, right? Let's say this trunk link. Is that okay? To answer your question?
Hi.
Yeah. Okay. Okay, hang on now. It's very hard for me to see who our voice when we are on the online, they change it like robot, sounding like robot. Sometimes hard to to recognize. Okay, all right. So I can see you guys. All right. Okay. Where was I? Yeah. Here. I was talking about this trunk links. Now, where else can we expect more than one VLAN traffic will need to pass through? Here, right? On the stick itself. Why? Because the router needs to perform its job to route between VLANs. So traffic from VLAN 10 needs to cross over, being forwarded by the router to another network, which is VLAN 20. So that means all traffic still need to go here. Okay, only if still, although you still all of what we learned about network still works here, yeah. Okay, which means if you are only sending traffic within your own LAN, within your own VLAN, there's no need to go up this stick, right? Remember, when you're trying to send something and the network address or the IP address belongs to a different network, what will happen? It will be sent to, what's the name of the interface here? Gateway, right? Okay, so remember that although we don't talk about gateway here, the sub interface becomes for that particular VLAN becomes the gateway, right? Become the gateway. So that means if you give the sub interface an IP address, that is basically a gateway address, because that's the address that your frames will be sent to, or your PDU will be sent to, because once your frame reach router, then we have to look at the frame as a packet, right? Your PDU is sent to the gateway being in the router, and is attached to that sub interface. Okay, that means we have two VLANs here, VLAN 10, 20. So each VLAN will have its own sub interface. So VLAN 10 will have its gateway address on that sub interface, right? So traffic that is going from VLAN 10 to VLAN 20 will be directed to the gateway, which is on the sub interface for that VLAN 10. And then it will be routed by this router, will be passed to the sub interface of VLAN 20, which is actually the gateway address for VLAN 20. Is that okay, guys? The theory, the idea is still the same as what we have learned about LAN. It's just that now we are, due to VLANs, then we have sub interface. Actually, it's just it's a logical interface compared to a physical interface. Right, so to route between VLANs, the R1 gigabit Ethernet 001, this one, right? Physical interface here, okay, is logically divided into three sub interfaces, right? Shown in the table, right? And then we also have three VLANs. I guess the native one is 99, right? So, excuse me. All right. So basically, the 99 is, if you think about the switch statement, your switch 10, switch 20, and then I guess 99, the native is the default one, right? Any traffic that doesn't get tagged travel through the native VLAN, the 99 here. Okay, and the sub interface for the VLAN is 1.3. So that's why we have three sub interfaces, one for each line, one for VLAN and one for. So this is the IP address because it's an interface on a router, right? Although we call it sub interface, but it's actually performing like a normal interface. So we have to interface on the router needs to be given IP address. So you can also say that this IP address on this sub interface is VLAN 10's gateway address. And then this one is VLAN 20's gateway address. And this one is VLAN 99 gateway address. Is that okay for that? Can you press
Okay.
Okay.
okay. Okay, fair. Okay, Kelvin. Okay, Noel.
Okay.
Okay. All right. So far so good. Now assume that router 1, switch 1, and switch 2 have initial basic configuration. We already know how to configure that one, right? All the password, host name, banner, the message of the day, all these are considered as also the management interface, right? All these are considered basic configuration that must be there, right? Okay, so currently PC1, PC2 cannot ping each other because they are on separate network. Of course, they are this one PC1 is on VLAN 10, PC2 is on VLAN 20, right? Only switch 1 and switch 2 can ping each other, but they are unreachable by PC1 or PC2 because they are on different networks, right? So to enable devices to ping each other, the switch must be configured with VLANs and trunking. This one, and this one. This trunk, this is trunk as well, right? And then the router itself must be
Sir,
yeah, sorry, yeah,
cannot see the cursor.
cursor. Sorry, what do you mean cursor?
Like
The
cannot see the
mouse.
arrow going.
Can I see the arrow?
Oh, my list. I put. Oh, I thought I put the laser. Okay, okay. Got. Can you see that already? Pointer, laser pointer.
Yeah.
Yes, can.
Now.
Okay, sorry about that. I already set it, but somehow it can disappear. All right. So I was talking about this lah, right? This trunk, this trunk. Okay. So if you don't set, of course, we already learned about the trunk links. If you don't configure that as trunk links, then they cannot talk to, let's say PC1 cannot talk to PC3. If PC3 is available, also VLAN 10. But if whatever it is, if you set this trunk link, PC1 still cannot talk to PC2 because they are in different networks. So we have router on a stick. We create this trunk because we need both VLAN and 10, 20, and 99 to be able to reach the router, right? And here they have each configured as sub interfaces, right? Okay. So you need to be able to configure. So step by step. Okay, normally configure basic configuration. That's normal, right? Then create VLANs, right? Create the VLANs, then decide which PC belong to which VLAN. Once you know that, that port connected to the PC must be set as access port, switch port mode access. And then you set that as what VLAN, because PC1, let's say PC belong to VLAN 10, configure that as VLAN 10. Do the same here, right? And then next, after configuring all your access ports, configure trunk ports. Okay, so between switches, trunk ports, make sure the list of VLANs that you want to travel through, you provide lah, separated by comma. Remember that? And then if you want to enable traffic from one VLAN to another VLAN, the link between the switch and the router configured as trunk link as well. So on the router configuration, don't forget, you need to specify sub interfaces, right? So think about if you are asked to configure, do it step by step, right? So here you can see, you create VLANs first. That's the first thing, because you need to know how many VLANs are you dealing with. Okay, identify which PCs belong to which VLANs, right? Management interface is part of the basic configuration for me, because you don't want to, you want to configure that as early as possible, the management interface. Why? Because you don't want to stand at near, inside the closet or inside the near the rack to just connect the console port. So for me, the basic configuration, I will have a list. Okay, I connect the console port, do my basic configuration. That means setting up the management interface. So after that, I disconnect. Now I know I can configure my switch, okay, from anywhere on the internet. In my LAN on the internet, if I open my firewall, I can allow connection from outside my LAN. Then I can access the switch. Okay, create management interface. Basically, that's the one lah. And you enable either telnet or SSH. Okay, if you trust your own LAN, okay, yeah, maybe you just want telnet. It's okay. Okay, but by habit, if you just create SSH, is better, because SSH is the one that is secure, right? So once you do that, then you need to start with the PC. Okay, start with the PC. All the ports from the switches connected to the PC, configure it as access ports. That's where you specify, of course, the design of all the IP address for which VLAN, the network address for each VLAN, the IP address for the management interface, the your uh, your PC, yeah, right? Your PC or your host, you've already designed first, right? And then only you configure. In the question, typically, let's say SBA, all the addresses usually are given to you like in a table. As usual, in our packet tracer exercises, we normally are given the table with all the address there, right? Right. Okay, so after you configure all the access ports, okay, now you identify which are the trunk links and then configure on each side of the port, right? So basically, when we're talking about each side is here, 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 here. Okay, you need to configure there, configure the trunking ports. This is to allow traffic, okay, more than one VLAN to traverse between the switches or between switch and the router. Okay, so step by step, so when if you're doing your SBA skill-based assessment, the practical test basically on week 7. Okay, you do step by step, right? And even better, once you do the exercises, okay, you can type out, your open notepad, you can type out all the commands, what's needed. Okay, so create management interface, what's the commands? Configure access ports, what are the commands, right? Not only is it good for your practical test later, but it's also good for when exam comes in. You can straight away identify if they, like in our tutorial, if there's some missing commands, okay, not provided in there, and therefore getting problems straight away. Oh, because I didn't put in command in there, right? Okay. Right. So these are the commands you can go through. You can see that the first few here is basically creating the VLANs. Okay, VLAN 10, 20, 99. to provide the description of the VLAN to make it more meaningful, you can provide name. Of course, here it's not meaningful. VLAN 10, VLAN 10. Of course, meaningful means, okay, so this one is maybe faculty, this one is student, right? So this one management. So management, oh, I thought this one is native, right? So this one is management, all right? Okay, use 99 as management. So basically, if you don't configure, native is still on VLAN 1. Remember, by default, all if you don't create additional VLANs, everything is on VLAN 1. All right. Okay, so then you configure the mode access, switch port mode access. That includes providing the IP address for that interface. Right? Sorry, not IP address. This one is management IP address. The VLAN. Okay. Providing the VLAN number for each the mode switch port mode access. Okay. This one management IP address. It's VLAN 99 interface, you can provide the IP address. Okay. I hope the no shut is already automatic for you guys. No shutdown. After every time you configure an interface, no shutdown should be the last command. Okay. After you configure, so that you ensure that interface is up. Okay. Right. All right, so switch port mode access, we provide the default gateway. The default gateway is basically the 1991 here. Here, 1991. The sub interface for VLAN here. VLAN 99. Right? That's the gateway address for VLAN 99. So you can see there. Right? Straight away you configure that also. Okay, for VLAN 99. Right, so and then you configure all the mode, switch port mode access, provide the VLAN for it, no shut, so that it goes up. These are the typical message from Cisco. Once you type no shut, it goes up. Right, so so far, we have not touched the trunk yet, right? We just configure the VLAN and the management interface, and on the switcher and the switch. Not sure this switch. This is switch 2. So switch 1, you can configure the same, right? Exactly the same. So that means switch 2 is recognize VLAN 10, 20, and 99. So switch 1 also recognize VLAN 10, 20, 99. Okay, and they should have the same configuration except this part. Right, because S2, oh, the trunk is here, sorry. The trunk is already configured here. For switch 1, please note that it's not VLAN 20, right? VLAN 10. So here is switch port mode VLAN 10. This VLAN 20. Just be aware of that. The creation of 10, 20, and 99 VLANs in switch 1 and switch 2 should be exactly the same, but the switch mode access different, okay, and also because it's VLAN 10, the IP address is different also. Sorry, it should be the same because 99 is still the same, right? For 99 right? 99.1. All right. Okay, and the trunk should be the same. Is it FA1 also? Yes, FA1. Okay. So the other configuration is later for router. This one should also be trunk. This one will be trunk. And then we configure the sub interfaces. So let's look at that. So R1 sub interfaces configuration. Right. So each, remember we have 3, right? 10, 20, and 99. So that means you have to create 3 sub interfaces, 1 each for the VLAN. Right. So sub interface is created using interface ID, and then sub interface ID, sub interface ID, right? So command should be yeah, there. Interface ID, sub interface ID. So sub interface ID is .10. So the interface ID is G001. Then sub interface ID is .10. Okay. When you put the description there, well, we know that interface IP address will be the default gateway for VLAN 10, right? And then don't forget to say that it's so that the sub interface is working on the protocol encapsulation .1q and then 10. Okay. Provide the IP address. This IP address must belong to the VLAN 10 network address. Okay. That means a valid usable IP address belonging to VLAN 10. Right. So that you do the same for the uh, VLAN 20 and VLAN 99. Right. And then the interface that is facing this is the physical interface. These are the sub interfaces configuration, but the interface itself you must configure as the trunk link. So this, put as this trunk link to S1. Okay, no shut. Oh, but actually maybe it's automatically. Once you set the sub interfaces, it becomes understood as a trunk link. I don't see the configuration here, but we can see the configuration for the switch. This one is for connecting S2 and S1. So S1 should have also this one switch port mode trunk at FA5. FA5 here. Okay. So, and this, it seems like there's no need to do this command switch port mode trunk. You can see only the description. Okay. So I'm assuming once you configure these three, it recognizes this interface because of here as a trunk link interface, right? So yeah, so all this explanation is basically this part. This is what you need to configure on router 1, right? So once you're done, both I think the only thing missing is this one trunk link here. That's not created because here the example is for S2. Okay, so for S1, additionally interface F or FA5, just do this also switch port mode trunk, no shut exit. Right. So once you do the routing, router sub interface configuration, we verify by using ping as usual. So what do you want to verify? You want to verify that all you configure okay, including the trunk link between the switches. So trunk link between the switch 1 and the router is able to route. Okay, so you ping address belonging to, if you're from VLAN 10, you ping the address of the PC2 belonging to VLAN 20. Right, so you can see I'm at PC1, I'm pinging the address of PC2, which is in VLAN 20. PC1 is VLAN 10. So when you see reply to this, then it's okay. Okay, so it means it works. Right. So you can test. Basically, you can test your ping to the PC to the other host. You can ping your own gateway. You can ping another gateway. That means whether the routing is okay or not. And you can also ping the management interface on the switch, right? To make sure that configured correctly. Okay. Right. So if you can ping each other, P1, PC1 to PC2, then you know the VLAN routing is inter-VLAN routing is correct already. Right. So yes, you can use ping, but you can also sometimes what if ping doesn't work? So if ping doesn't work, then you have to do troubleshooting, right? Troubleshooting means you have to go inside the devices. So you can, if you go to the devices, um, so for router, you can type there show IP route. Okay. I don't think you can do show IP route um, in those with IP lah, in switches. So show IP route and show IP interface brief. This belongs to the um, routers lah. You can type this there, so you can see your configuration, your sub interfaces, and whether routing is enabled. And then for switches, you can also do show interfaces. So interfaces trunk to see whether your trunk link configured, and mode X, the switch port mode access also configured correctly with the correct VLAN. Okay, and correct VLAN and correct IP address specified for it. Okay, so exercises related to this just now is coming soon, coming in Friday. Is to add VLANs to a switch. That means you create VLAN, provide the name, right? And then on the router itself to configure sub interfaces, and then to use ping and also troubleshooting using the show commands early on, right? To test connectivity, whether your inter-VLAN routing works or not. Right. So okay. So I think we'll do this in our practical this week. Right. So just now we look at router on stick. So this is the third option. We learn how to configure using layer 3 switches. Configure inter-VLAN routing using layer 3 switches. Right. So
do they check all the VLAN coming in?
they being which one? A router?
Or the router?
They check all the VLAN. Yeah, they should check, because
if too many go in, will it cause problems to the router?
Yeah, I think so. It will be, because you can see, because the sub interfaces are basically done in software, right? So as usual, when it comes to software, the software needs to be interpreted by and then executed by the CPU. So you do have a CPU inside the Cisco router. So what you're describing is similar to if our PC, the utilizations go all the way to 80-90%, then you'll see that the PC start to lag. So router is the same. That means you're describing too much traffic. Too much traffic.
Oh,
So
okay.
if your router, let's say, here we only have 3 sub interfaces because we only have 3 VLANs. But if we go, because the maximum is 50, let's say you go all the way to 50. So you have and you have a router on stick that caters one large LAN that is segmented into, let's say, 50 VLANs. So that means you have 50 50 sub interfaces. So they are all software based, means they have to be executed using the CPU. And the CPU inside the router is special purpose, right? But it's not as powerful as any of the desktop, CPU. So of course it will introduce latency there. It will still be able to do it, but I think it's going to lag because of that. Right?
Okay.
Yeah. Answering your question, do they check all the? Yes, as long as you set the sub interface and you you configure the sub interface with a VLAN, then traffic from that VLAN will come in through that sub interface. Okay, that means because it's trunk link, right? Trunk link. So that gigabit interface, the frames are flowing in, right? Frames flowing in. So, and then it will be relayed to, depending on the tag on the frame. Oh, this one is VLAN 10, go to this sub interface. Oh, VLAN 20, go to that sub interface. You know, there's a process where the incoming frames check for the frame tag and then identify which VLAN it belongs to, and it's passed along to which sub interface. Once it reaches the sub interface, then the routing process that we already know what's going to happen there, right? Routing process will be done for that particular frame packet on that sub interface, right? So imagine if you have 50, yeah. So it depends, lah. It depends on how many VLANs sub interface you created. But if you have created three, all three, yeah, of course the router will accept from all three. So will accept, that means not accept from all three lah. Terbalik sudah. You accept all traffic from the gigabit interface. Then you identify the content of the traffic, which frame belongs to which VLAN. And then once identified, you forward the frame to the correct sub interface for that for which VLAN. Let's say I receive a few frames. I check one by one. The first one, oh, I check is VLAN 10. I pass to the sub interface for VLAN 10. Next one, VLAN 20, pass to VLAN 20 sub interface. So, of course, if the VLAN, the frame coming in, you check the VLAN tag and you don't have a sub interface for that, it will be dropped. So that's why I said it depends on how many sub interface you created that deals with the different types of VLANs you have inside your network. So even though you create 50 VLANs, but you only create 2 sub interfaces, so only the 2 will be accepted to be and passed to the 2 sub interfaces lah. So that's why very important. If you have 3 VLANs, then you want network traffic to work for the 3 VLANs. On the router, you need to create the 3 sub interfaces, each dealing with the specific VLAN. Is that okay?
Okay.
Right. All right. Okay. Yeah. So here again is a recap on the reasoning with why inter-VLAN routing is only suitable for small, medium-sized organization. Just now we talk about it, right? We talk about the maximum 50. So and it's all software based. It becomes it can introduce latency a lot. The more VLAN you ask the router to process, right? So it says here, larger enterprise requires faster, much more scalable method to provide inter-VLAN routing. So this method is this one, layer 3 switches. So layer 3 switches use hardware-based switching. Hardware-based simply means the circuit already, circuit there provided by layer 3 switches. Okay. All right. So this is the part that hierarchical network design I was talking about Cisco promoting it. Okay. When you have large network, say enterprise, so you design your network in terms of distribution layer hierarchy, right? So routers actually lives at the edge of your network. The means the device that connects you to ISPs, right? But inside your network, you still want to have segmented networks. So you, instead of having a router inside, you have multi-layer switch. All right. Right. So its capability route from one VLAN to another using SVIs, convert layer 2 switch port to a layer 3 interface. Now, switch port is layer 2. It's thinking in terms of frames. But once we say we need to allow to route layer 3, then the port has to become an interface. Means you have to be able to specify address, right? So there's a special name for these layer 3 switches. When you convert the layer 2 switch port to layer 3 interface, means you have IP address for that. Okay, that's why I always differentiate between interface and port in the terms that interface usually meant that you can assign an IP address to it, right? So like multi-layer switch allow you to change the switch port to an interface, otherwise known as, or also known as, routed port, right? So this routed port, by definition, because it has an IP address, you can configure IP address on it, means it's the same as a physical interface on a router, right? So SVI is the technique that layer 3 switches use for routing. Okay, so SVIs, how to configure it? Use interface VLAN, your VLAN ID, and that's it to configure SVI, right? And you use this same command for the management SVI, right? Okay, for layer 3 switches SVI, you if you want to configure the interface on it, then you use the same command as well. Right? So the layer 3 SVI must be created for each VLAN you create. Routable simply means you decide which VLAN you allow access outside. Outside here means to a different VLAN. If you want to isolate a VLAN, then don't create the SVI. Then the means traffic is only within that VLAN itself. But if you allow the VLAN traffic to go to another VLAN, then you must create the SVI to allow it to be routed. Right? So here you can see an example. Again, PC1, PC2 connected to this multi-layer switch, right? So this part of the network example is configured as VLAN 10. Here is the other side is VLAN 20, right? So if you think about it in functionality wise, this one exactly like a router. That means it allows routing, right? Because this is different on this side, it's a different network compared to this already. You can note this network address here. 192.168.10. This one is 192.168.20. So you know there are two different networks, right? Okay. All right. So yes, let's move on to this part. Okay. So how do you configure a layer 3 switch to allow this inter-VLAN routing? So first step, create the VLANs as usual. Okay, so VLAN 10, and then you can provide the name. Same way you create VLAN earlier on in the switch. Then step 2 is to create the VLAN interfaces. Okay, don't forget, when you create the VLAN interface, you need to provide the IP address, because now it's a routed port. Means traffic entering the port can be routed, right? So the IP address that you configure for that VLAN interface, let's say this one, becomes the gateway for this network, which is VLAN 10. So that's why I configure as IP address 1 for that, IP address 1 for this network for that. Okay, this is gateway for VLAN 10. This one is gateway SVI, yeah, interface gateway for VLAN 20. Right, so once you do that, then you can configure the access ports. Where's the access port? Same port is actually is also access port. This is the why we say it's multi-layer switch. It can perform both. It can perform because access port is actually done by the switch, right? In the switch, you have to configure access ports, but this multi-layer switch. So in addition to the port of the switch that's connected to the host being configured access ports, that's a functionality in layer 2. You also do this, configure that port just now become interface. We call that a SVI, right? So that it serve both purpose lah, right? Both will be switch. The switch will it will act as a switch, but it also act as a router, right? Then after you configure all the access ports, of course, configuring all the IP address, gateway address, all this on the PCs, yeah, then you enable IP routing. Within the multi-layer switch, just issue the IP routing, global configuration command. Then it will start to enable routing. Then you'll find that traffic from PC1 can reach PC2 and vice versa. Right? Okay, so as you can see, it's so easy to configure, right? We basically don't need to configure on a router on a stick, right? It's there are more things you have to configure, right? You have to configure the trunk link on the switch connected to the router, and then you have to configure the router sub interfaces and so on, and then you enable the routing in the router. Okay, so it's a little bit simpler to configure layer 3 switch, okay, compared to router on a stick. Okay, so after we complete that just now, we can verify by doing ping again. Ping means try to ping from a host from a different VLAN to a host in a different VLAN. If you receive replies, then that means your traffic is routable between the two VLANs. Right? All right. Okay, so if VLANs are to be reachable by other layer 3 devices, then they must be advertised using static or dynamic routing. Enable routing on layer 3 switch, a routed port must be configured. We already know that routed port is SVI just now, right? So how do you switch between normal switch port to a routed port? Well, we disable the switch port feature, right? So you basically use this command, no switch port, and what is your interface, right? After you do that, it will convert from being a switch port into a routed port. Then you can configure SVI on it, right? Okay. Any questions so far?
No.
No, straightforward, can? All right. So here's one example, right? So if you see this OSPF, this is basically part of the content when we talk about routers. I think we're going to talk more about this in detail later. Right now, not really important for us. Okay, so let's look at the scenario. We have a server, and This router connects to our server. This part of the network is 10.10.20. Okay, and then this part of the network is 10.10.10. Right? So this is this router 1 gigabit 1 is 10.10.10.1. Okay, and then here is 10.10.10.2 on the multi-layer switch. All right. So this server is basically belong to VLAN 20, right? VLAN 20 because no, it's not. It's not. Sorry, it's not. I was expecting to see 10.10.20 here, but it's not. So that means this is a different network. This is a normal network, not VLAN network, with different network address. Okay, so that means traffic from VLAN 10.20, right, is being routed between VLAN 10 and 20, right? But if they want to reach out to, let's say, server, then need to configure the routing, right? So that means here is your gateway for VLAN 10, gateway for VLAN 20, right? So these already act as their gateway. And when you reach here, depending on the destination, it can either, let's say, go like this. If you want to talk to PC2 or you want to talk to server, you still use this as your gateway. So this multi-layer switch will route. Okay. Route. First of all, of course, we stop here first in the router 1, and then router 1 will then consult its table and forward it to server. Okay. Since this D1 acts as a router, okay, so that means it has a routing function, which means it can also work on the routing protocol. Routing protocol basically just simply ask D1 will ask router 1, and router 1 will also ask D1 about its connected networks. We still remember remote and local connected networks. So for router 1, this is its connected network, this here and here. And these two will be its remote networks. For D1, this is its connected networks, and here it's its remote network. Okay. So basically, the multi-layer switch allows us to have functionality of a router, okay, within our own organization. But it also acts as a switch, right? So you notice that there's no switch, okay? So it's a switch and a router at the same time, okay? So let's say you don't have VLAN 10, VLAN 10, 10 and 20. Let's say this is normal network. So this basically, this is overblown switch here. All the routing is disabled, but it works just like a switch, right? Suddenly, you configure this one VLAN 10, this one VLAN 20. You configure D1 to become a router. So this one become routed port. Now suddenly, there's no switching. It becomes, because it's directly connected, it becomes a router. It can perform both functionalities. Right.
Is it so the D1
Yeah.
can be both a router and a switch?
Yeah, it can be both a router and a switch.
Ah,
But in this scenario, if you have this PC1 belonging to a VLAN, this PC2 belonging to another VLAN, right? Then this D1 now acts as a router. It's not switching anymore because switches only works inside a LAN. This is two LANs. This is one LAN. This is one LAN. Right?
yeah.
You get what I mean? So now it's totally not doing switching. It's doing routing. It's become like a router only. Is it okay?
Okay.
Yeah. That's why if you start to use VLAN, then I don't think you should do half-half lah, because it means, oh, these PCs belong to VLAN 10, these PCs belong to VLAN 20. What about these PCs? Oh, just leave it. So they become native lah. Native. They become they work on the native VLAN, but still they are part of the VLAN. That means if you, let's say, connect here, and then of course this PC doesn't work, they cannot connect because they are different address. They are not part of you didn't configure as VLAN, right? So they use the native lah, right? What else can they use? They cannot use already. But native is also belong to VLAN. Let's say what did you configure as default as 1 or 99? So still, then this still becomes a router, routed port, or else the native VLAN cannot pass through. Do you see that? Think about the scenario. Yeah, think about the scenario. You cannot have mix, right? If you have start using VLAN, if you have some PCs not configured as connected to VLAN, then it doesn't. That means it becomes part of the traffic becomes part of the native VLAN, and it's a VLAN anyway, right? It's either you use VLAN or you don't use VLAN, right? Right. So this is a routing configuration layer 3 switch. Okay, to transform D1 to become, to become a router that can route to R1. Step 1, configure routed port. Those port that connects to the PC. You can also connect the D1 to another switch. So in that case, you probably won't need to create a trunk link, right? If the switch connect to different hosts that belong to different VLANs. I mean, it depends on scenario. So here, you could have connection here, a switch, right? And if this switch only linked to VLAN 10, VLAN 10, VLAN 10, okay, this one can be no need to be a trunk link or trunk link, but still can be a trunk link enabling only VLAN 10. But then if this is also VLAN 10, VLAN 10, and then VLAN 20, then trunk links. You can extend, right? But then again, this still becomes a routed port. Now, whether you can configure this as a how to say this as a sub interface, I don't think so. So can you still mix? Let's say it's VLAN 10. Here is VLAN 10. This is VLAN 20. VLAN 10. Because this is a single SVI interface. There is no sub interface for SVI. There is no sub interface as in a router on a stick. So what does that tell us? How do we route? Would it be routable? Would this be routed routed port or normal switch? Normal switch port.
Oh, the red one.
If it's a normal switch port, then this can be a trunk link, and this basically perform the switching. Because just now I was just answering your question. can it be switch and router at the same time? Right? The scenario we are given is a switch or router. Okay, so if router and switch at the same time, meaning to say some are routed port, some are switch port.
Or it can have two types of port at the same time.
Yeah, because it's different ports now. Yeah,
Okay.
you connect to different ports. The routed port and switch port you configure per port. Yeah.
Okay.
Yeah, it's per port. Remember the command to you just put no switch port, then it becomes routed port, right? If you want this to be a routed port, then you cannot have V10, V20, V10 because here we cannot have sub interface. Right? If you have this situation V10, V20, V10, and you want to be able to switch them, right? Then this one become switch port. But if this is a switch port, means you cannot route them. Can you see that scenario? Means the V10 here and V10 here can only talk to V10. Use a switch. You cannot traverse to talk to V20 unless this become a routed port. But if this is a routed port, you cannot have V20 as part of this LAN here. Do you see why? Because it becomes a routed port, you have to specify that gateway address. And if V20 belong to a different network port, so if you set it for VLAN 10 gateway address there for this particular segment, then V20 cannot traffic cannot be forwarded outside. So V20 traffic can only flow inside this LAN.
Even if the become trunk, if it
Yeah,
become trunk,
because
it will be okay.
yeah, because this one become routed port, there is no way. It's not switch port anymore. If you don't convert to routed port, it becomes switch port. Then V10 and V20, well, as long as you put this as trunk link, can get into D1. But then, because D1 is no longer switching it, so V10 we can only talk to another V10, even outside this segment.
Okay.
So V20 can talk to only V20. So it depends how you set up to make full use of this multi-layer switch. Okay, so that means you design best is probably this way. If you want to extend, you make sure the segment where you extend using another switch is now it's either the same VLANs and then so it become routed port, or if you separate them with V10 or the host connected to that switch, then this one become switch port rather than routed port, cannot be routed. Okay, yeah.
Okay.
All right. Okay, so yeah, enable routing on the layer 3 switch. Use the IP routing global configuration command to enable routing. Same command you'll find that you can use on a router, right? Configure the routing. Use appropriate routing method. Single area OSPF version 2 is configured. So okay, don't worry about this first. Okay, we'll encounter this later again for the routing configuration. Right, verify routing, show IP route, and then use ping to ping between networks, between VLANs. Right, so for packet tracer, to solidify your knowledge in this section, you learn how to configure layer 3 switch, configure the inter-VLAN routing. Remember the port change to router port. Enable the IP routing, then you can route. Okay, and well, basically IP version 6 was just set the additional IP, just like in a router interface, you can set both IP version 4 and IP version 6 address. Then for the routing, you enable IP version 6 routing. Then it will forward IP version 6 packets as well as IP version 4 packets. All right. Okay. Any questions so far?
No.
No.
No, Kelvin?
No.
No. Okay. So the last section is all about troubleshooting. So what do you want to watch out for? So once you configure and you find that your ping doesn't work, then you want to troubleshoot. Okay. So inter-VLAN routing, because now you have to make sure your VLAN all works, right? Then after all your mode access, switch mode access all works, then you check your switches, right? If it's a multi-layer switch, it's already changed to switch port, changed to routed port. The correct address is configured for that particular PC, right? And then after that, you check whether your routing is enabled. Okay, so here we have a look at the very common issues that because we are not experienced. A lot of network administrator or network engineer that is experienced already go through a lot of these problems already, so they already know, right? So since we are not experienced, we need some guide lah. We need something to tell us, some info that tell us, okay, so if we got problems, is there a systematic way, or is there any clues for us to, okay, what do I check for, right? And what can I do to troubleshoot? What do I do? Do I go to the switch? Do I go to the multi-layer switch? So let's see first what are the problems that can happen. Okay, so you look at this this slide. It says missing VLANs means you either typo in creating the VLAN, or you miss out one of the VLANs. Okay, this is on the switch. On the switch, you create the VLANs. Okay, the ones that you say VLAN 10, and then we put the name and all this, right? Okay, so how do you check whether any VLANs is missing? Just show VLAN, and then VLAN will show more info. Show VLAN brief, then just show you what VLANs are available, right? And then check the interfaces, which VLAN is assigned to which interface, because this one also you have to configure properly, right? So show interfaces switch port will show you the interfaces on the switches and what VLAN is assigned to it. How to fix means, okay, if it's missing, then you have to create. If it's typo, then recreate. Type no in front, no VLAN first. Okay. Now, there's one caveat. Remember, interface can go missing if you delete VLAN. So that means the best way to do is, if you want to, there's a typo, you want to remove that one, that mistyped VLAN, you want to recreate it. If there's any interface assigned to that VLAN, set all those interface back to VLAN 1, which is our default. Then delete that VLAN, recreate that VLAN. Okay, making sure no typo this time. Then reassign the interface to that VLAN. Is that okay? That's the proper step lah. Okay. Right, and maybe switch trunk port issues. Why we need to have trunk port is because switch to switch, or switch to router and stick, switch to router. Remember, sometimes we still small companies, I can't imagine why you want 50 VLANs. So most of the time, maybe you don't buy the multi-layer switch, right? Maybe you have a router. I don't think small, medium size can go beyond 50. I mean, can even reach 50. I mean, 50 segments, network segments, 50 local area networks, because 50 VLANs. So at the most, if your company maybe got marketing, sales, accounts, HR, like maybe you reach 10, I think it's quite a lot already, again. So still achievable with the router. Okay. In any case, that means trunk port can be between switches, can be between switch and the router on the stick. So you want to check whether those trunk ports are correctly configured. One of the things I noticed also that you forgot to include one of the VLAN ID as part of the trunk port. That means that VLAN traffic doesn't pass through. So let's say you're pinging from the PC belonging to VLAN 10. Straight away, show interface trunk, you can see, oh, is VLAN 10 part of the trunk assignment? Right? Straight away you can see. If it's not, oh, that's why I need to add in, or else the VLAN 10 traffic cannot pass through the trunk link. Okay? I assume all the no shut, you guys know already, you have to type no shut, right? So that's the basic thing. Don't forget the no shut. Sometimes you don't work. Then the actually the port is not up because, well, you can it will show you that when you say type this command show into strong or show running config, you can see whether it's up or not, right? So sometimes you do forget to type no shut. Okay. Third one, switch access port issues. This one is the one, the port that's connect to your host, to your PC, right? See whether the port is assigned with the correct VLAN, right? And see whether the VLAN assigned to the port is correspond with the network address, the IP address that host is assigned with. Yeah. And of course, the host also will need the gateway address, gateway IP address. See whether that one also is the correct IP address as assigned to, if you're using router and switch, the sub interface, if you're using multi-layer, to that SVI interface, right? And then router configuration issues, the router sub interfaces all correctly match with the VLAN and the IP address. Okay, sometimes we make a mistake lah. So that's why when I'm doing this, I usually type all the commands in Notepad. So switch one, then what commands configure, basic configuration, and what. Switch two, and so on. Then I just walk through, like walk through a source code. Walk through, did I miss anything? Okay, I'm confident. I just copy, paste into the switch one or iOS, right? So if there's something wrong, I can definitely know, okay, these are the commands I put in, which command I forgot to put in. Because it's very hard. You type one line after one line after one line. It's very hard for you to remember what have I put into. Did I remember to put in this command? Well, for me personally, I have that problem. I go back. Did I enter this command? I have to type show bridge. Yes, you can do that. But for me, the best way, I type all my commands in Notepad for switch one. All right, so these are the commands, right? So I know for sure if I copy paste that one inside, I know I already, these are the commands I already type into switch one. These are command for switch two and router one and so on. Okay. Better lah. better to do it that way. For me, is make it easy for me to track what I've already configured and exactly what I configured. I don't have to press the arrow key up to see, oh, what did I type? What did I do a typo? Did I type typo? Whatever. I can straight away see, right? And definitely, once I do all the configuration, I troubleshoot, I adjust my answer, right? And then as simple as that, to redo, I switch off, switch on my switch or router, just copy paste again, right? Copy paste the corrected one. Then I do verification. It's quite fast because sometimes when you're doing these exercises, tests, uh, including CCNA, they have within a specific time. So you tend to want to do things quickly, to test, to verify, to type in the, right? So for learning, okay, type command by command. For doing the practical test for SBA, okay, you want to do as fast as you can. So you can also do my technique just now, right? A lot of those people going for CCNA, they use this technique to speed up the configuration on the, right. So you see the students that go for the Cisco NetRider competition, right? Every year they have this, and Thai UC uh, always turn out either winning or getting first, second, or third, or combination of those. That means when it comes to Cisco CCNA configuration, our students are quite good lah, right? So when it comes to that, that means you have a set time. That's the best way to do it. Okay. Right. So the last part you need to check is the router configuration issue. Router sub interface IP address correctly match. Okay, correctly put in. Sometimes IP address also typo. And the router sub interface also, instead of typing .10, you type the dot one something, maybe a typo lah, right? Sometimes when we type, we can't, and then we enter and it's called up already, we forgot already, we cannot check. We check one, but it's too slow, right? So yeah, router sub interface assigned to the correct VLAN ID. Right. So examples of some of the routing problems we can see here, right? The topology we'll use will be the same topology here, right? And the router sub interface is given there. Okay. The interface dot the interface the sub interface ID. So this part. Okay. So 3 sub interfaces there. Okay. And does it need to match 10, 10, 20, 20, 30? See, there's no need to match. But if you try to match it, it helps with the configuration, right? For us, it helps us to align a 10 is 10, 20, 20. Okay. Here, well, I can put 99, 99, or 30, 30, right? But as much as possible, we try to do this because it makes it easier when we are configuring, right? Okay, imagine if 10 and then here like 25, here 15, and then no rhyme or reason, right? You make it difficult and make it easier for you to be confused in your own configuration. Yeah, when you configure it, then you confuse lah, right? So if you base on question, usually the question will tell you like what, VLAN 20, 10, all this. But if you're working on it as a practitioner, I think it's good also to to do the meaningful sub-interface ID. Okay? Right. Okay, so the first one is missing VLANs. Missing VLANs means you either forgot to type or to include or to add one of the VLAN. That means you try to test. Of course, the switch doesn't understand or doesn't recognize that VLAN because it's missing, right? Or it could be accidentally deleted. To delete is just put no in front. Okay, quite hard to accidentally delete lah, right? Because you have to type no in front of the command, right? Or maybe you left out the VLAN from the trunk link list. So then it's not configured to be transported across the trunk link, right? So this is what I was thinking earlier on. If you delete let's say you're doing your editing, your VLAN is deleted, all the ports assigned to that VLAN become inactive. So better you reassign those ports to maybe the default VLAN, delete the VLAN you want to delete, recreate the VLAN, then reassign the port to the VLAN. In that way is much better lah. Okay. Right, to verify VLAN membership, use this show interface ID switch port. Right. Switch trunk port issues. Right. So misconfigured switch ports. In legacy Inter-VLAN solution, well, no one wants to do this anymore because it depends on the router having enough interface for the VLAN. But if you're still doing this, right, that means the router port is not assigned to the correct VLAN. Okay. So for the router on a stick solution, if you use the second method, that means you misconfigured the trunk port. Verify that the port connecting to the router is correctly configured as a trunk link, right? Using the show interface trunk, the switch, the switch must be set as trunk port connect so that the link between the switch and the router is a trunk link. Okay, so show interface trunk. So let's say FA01. Let me see from over here. FA01. But these two FA01 on S1, FA01 and S2. This for this is FA05 on S1 and on the router. Okay. Right. So router and the stick solution. So if I am on S1, show interface trunk. FA01 on, this one is connected to S2, right? FA, you can see that VLANs allowed. This one is connecting to the other. So I don't think this one is connecting to the router one. Router is FA05 configuration on the, yeah. This one is the one create the trunk link between switch 1 and router 1. So FA1 on S1 is trunk link to switch 2. Okay, and we have the default VLAN 1, 10, 20, and I think for this example 99 is management VLAN, right? Okay, so far so good, right? Encapsulation as well. Okay, that's correct. But switch access port issues. Access port is near the host, right? So if you suspect a problem here, you have to check. Let's say show interface. I think this FA06 on S1 is a switch port connected to the PC1. I think, yeah. So just type show interface F06 switch port. then you can see it should be static access, right? Access mode VLAN 1, no? Right? VLAN 1. So I think the problem is if you see this VLAN 1, it should not be VLAN 1, it's default. So it's either 10 or 20, right? And native for, I think native for the management port 99, right? So check that whether the correct VLAN is assigned to the access port. And another common issue here is your IP address assigned to your PC, which is your host, belongs to the same network address that is assigned to the VLAN. Okay, right? And of course, when you provide certain IP address, you must provide the correct subnet mask for that IP address. Okay, and the default gateway, then you have to check if it's router on a stick, then look at the sub interface IP address. The sub interface belong to the same VLAN as the PC, and make sure the default gateway at that sub interface is in the same network address as that VLAN that PC belong to. Check the PC's default gateway. Is it the same as that IP address assigned to that VLAN sub interface on the router? Okay, these are the commands that you can type to verify all this, right? Meaning, just now, what I want to say is, let's say this PC, this gateway is the sub interface in router 1 for VLAN 10, right? So make sure on the router that is the same as this PC belong to VLAN 10 configuration. Okay. Router configuration issues. Yeah. We talk about this sub interface problem. Either the sub interface created with the incorrect VLAN, that means typo, right? Or you didn't create the sub interface, or the sub interface configured with the correct VLAN but the wrong network address for that. Yeah, that means the interface address is belong to the wrong network address as belonging to the VLAN that you configure for that sub interface. So to check, just type show IP interface brief, right? And you can see each interface and sub interface, what are the configuration that was set on it, and then you double check, right? Okay. Right, so this is a shortcut because we're using sub interface is using this protocol at 02.1q. So this pipe here is like a filter. So you provide this include, and then the keyword here is this. Then it will filter the long list only to the sub interfaces. Then you can focus on sub interfaces, right? Okay. Right. So packet tracer exercises, okay, related to these topics that we just look at, right, is to locate, that means troubleshoot, to locate network problems, implement the solution, verify network connectivity. You notice that the question that you get from your tutorial is very similar to the packet tracer problem, right? Instead of you having to do the troubleshoot, the question already gives you some of the result there. Then you just identify and then write down what you think is the problem and implement the solution. This is typical of this course question. So expect to see this kind of question coming out in the tests and exam. Not all of them, but maybe one or two. Okay. So it means if you do the packet tracer exercises, right, it not only helps you with the SBA, the skill-based assessment, but also helps you with the test and exam. Okay, because when you're doing the exercises, um, you basically expose more towards the what's going on with the topics, right? In practical way, you will remember. Okay, so the question when it comes out, they usually scenario this, scenario that, and then they give you exactly like in your tutorial. You'll be more able to answer if you do the practical exercises, right? Okay, so there's a lab related to this, build network load device configuration. I think we did this one, and then troubleshoot. Okay, I think uh, we've talked about the theory part, all this already. It's just left to do it. So this Friday we're going to go ahead and do it. Yeah. Okay, module practice and quiz. Now I have already opened up for the previous chapter and this chapter module exam. Each one I allow 10 times, and you can at your own time freely go through and try to do the it's MCQ, right? But some of the question will maybe require you to open up your packet tracer and the question related to packet tracer. Okay, I do urge you to try out those chapter exam and also the packet tracer exercises. Right, so we have here Inter-VLAN routing challenge, implement Inter-VLAN routing. Right, so let me just double check our practical is coming. Config in this coming Friday, we're gonna do VLANs and trunking and configuring router and stick Inter-VLAN routing and in troubleshooting Inter-VLAN routing. I think next week our lecture we're going to start to look at spanning tree protocol, STP. Remember the circular flow of traffic, okay, inside a network. We want to prevent that using STP. And the ether channel, the bundling of more than one cable between two switches. If you have more than one cable connecting two switches, you can bundle those cables together logically, to create a higher bandwidth pathway. So that's called ether channel. So I think these are the next two chapters we're gonna look at, right? And we can configure it actually. All right. So what did we learn in this module? VLAN routing, allowing us to forward network traffic from one virtual LAN to another virtual LAN. This is an improvement to the previous chapter. Previous chapter, we create VLANs. Then we know within the VLANs, hosts can talk to each other. But in this chapter, we allow traffic from one VLAN to go to another VLAN, right? So three ways we can do it. Legacy, okay, but legacy is not really done because it depends on how many interfaces we have on a router. Okay, if we only have two, then we only can create two virtual LAN. Router and stick is better because the interface is virtualized, sub interfaces, right? And it's good for small, medium size, so up to 50 VLANs that you can create. If you need more than that, then we have layer 3 or multi-layer switch using SVIs. So we learn how to configure switch with VLAN and trunking, right? Creating and naming the VLAN, creating management interfaces, configure access ports, and configure trunking ports. We also configure sub interfaces, and then assigning an IP address on the sub interfaces. The IP address on that sub interface become the gateway address for the virtual LAN configured for that sub interface, right? And we look at layer 3 switch, okay, routing using layer 3 switch and configuring or enabling the switch port becoming routed port so that we can use the layer 3 switch as a router to route between VLANs. Remember that, Ken? Right. So, yeah, I think we also learn about troubleshooting. I think this is talking about that, yeah, talking about all the issues. So I think this one is a good like list for you to check when you're doing troubleshooting, right? All right. So some more notes about what we learned. I think we already mentioned this. Okay, so I think that's all for this session for lecture. So I'm gonna stop recording first. Right, shall we go for a quick break before we continue with our tutorial? 10 minutes?
Okay.
10 minutes, yeah? Okay, Farah. Noel? Kelvin?
Okay.
Yes, in 10 minutes, around 3:40 lah, right? Okay, so we resume at 3:40. And can we use the other Meet? Okay, I'll see you in the tutorial Meet. Okay, guys?
Okay.
Okay.
All right. Three, okay, under tutorial participation. That's also assign all of you into the tutorial question. Right. All right, so the first question, tutorial 3, with reference to following diagram. Let me just share my screen. Right, you can see the tutorial 3 on the screen now. With reference to following diagram, identify the type of inter-VLAN routing and explain the limitation of this inter-VLAN routing. So out of the 3 that we mentioned earlier on in the lecture, which one is this? Is it the first one, second one, or the third one? Right. So Noel identify it, and then Kelvin explain why what is limiting this kind of solution for inter-VLAN routing. Right. And secondly, second question, a junior network associate has set up router on a stick inter-VLAN configuration as depicted in 2.1. Right. So the router is there. Okay. And that is the switch. So this router on the switch stick, right? And the basic equipment is to set up two VLANs, which are VLAN 301 and VLAN 303. PC A and B are in VLAN 301, whereas B here. Printer C is VLAN 303. VLAN 301 is assigned to the first subnet. Okay. And VLAN 303 assigned to second subnet of 192.168. So first subnet will be, if this is this this is a subnet 192.168.10.0. First subnet will be, and then second subnet will be what? Right? So you can see 301 IP address is 192.168.10.125, and the other one is 129. So subnetting lah, divide the 2/24 into two using the subnetting. Then the first subnet belongs to 301 VLAN, and then the second subnet belongs to 303, right? And okay, identify 6 configuration error in figure 2.1, 2.2, and 3.2.3. Document the configuration error and give correct solution using 2.1 in your answer. So 2.2, 2.3 here, right? Then identify the 6 errors lah. Yeah, 6 errors. What error do you think it is? So you find 2 each. Noel find 2 errors. Kelvin 2. Farrell find 2 errors. Now question number 3. Identify the type of inter-VLAN routing and explain the steps to configure this type of inter-VLAN routing. So not this icon here. Okay, what kind of inter-VLAN routing are we doing? So Farah, identify this type of inter-VLAN routing. And Noel, what are steps to configure this type of inter-VLAN routing? Okay, the steps basically you can find back in the chapter just now in the lecture. Okay, Noel. Right, number 4, a network administrator has received a complaint that PC10, this one, PC10, on VLAN 10 and PC20 on VLAN 20 cannot communicate. Based on the information and configuration shown in figure 2.1, identify the configuration errors based on this. Right, so if this is not clear, you can see the PDF version. I already shared in tutorial questions, part of tutorial. The PDF version should be clearer. Okay. If you find it hard to read this text here on the question, right? Explain your answer. Okay, so you guys have a group. This one, number 4, you share to answer. You have a group discussion. What's the error? And fill up the table, right? So in this question 4, the number of errors is not given. So you need to have to try to figure as many error as possible you can see from the configuration given. Okay.
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 Hello, Farah. I just saw your message. Is that from question 2? You cannot find error.
Yes, yang the one to find the configuration, the error.
Okay. All right. So it's basically just if you not experienced to do the configuration yet, you probably cannot see straight away. So my advice is um, you check what is given on the diagram. For example, the two that I corrected already, is the first one. It says in router 1 under sub interface G001.303, right? So you look at that router 1, this one, right? Okay, I'm highlighting it, yeah. So on that it says encapsulation. Sorry, 3003. Sorry, here. Here. So this command is basically to configure the sub interface. So G001303 encapsulation dot 1Q33. So immediately you know it should be 303. So that's why correct lah, 303 solution. And this is wrong, right? You can see here it's done correctly. Okay, sub interface 301 and then .iq is 301 as well. That means we encapsulate using the .1q protocol for this sub interface, right? So here there is no sub interface 33 because the sub interface we configured is 303. So that's why the configuration error is this we indicate. So the correct one should be, we should type encapsulation .1Q303, right? So that's how, that's one way when you go through the configuration, when you try to see what's the error, okay? So definitely you need to refer back, okay? You're not sure what's the commands is meaning, yeah? You have to go back through the notes or the slides that we have. There are some configuration example there that you can use as something to refer to lah. Right. So another example, question number 2 says in R1 under sub interface, same sub interface here, the IP address given is 126. So you can see that the configuration is done here. After encapsulation, we need to give IP address to that particular sub interface, and we give 126. But then, what should it be, right? So how do we know which one is the correct one? Well, this is basically um, 303, right? 303, that means our VLAN is VLAN 303. So let's see the host, okay, that is configured with VLAN 303. So printer C, right, is configured with VLAN 303. And printer C default gateway is 192.168.10.129, right? 129. So 129 means the sub interface for VLAN 303 should be IP address 129. Yet we configure here 126. So that's wrong also. So instead of 126, in order for the printer to be able to be routed by the router, the default gateway, that is the sub interface for VLAN 303 at router here, must be set to 192.168.10.129 instead of 126. So we say this is the misconfiguration. We set it to 126, but actually it should be 129. Right, Farah?
Okay.
Yeah. So try to look at the configuration and the diagram. see is there any disconnect, or the something not the same, or some configuration that is done but not the same as what is shown in the diagram. Okay, you try first and check and see.
Okay.
Oh, okay. Item number 1, switch number 2, FA1 should be trunk to allow both VLAN 20 and 10 to access. So S2, FA1 should be trunk. FA1, isn't it the access mode?
Oh yeah, access mode, but you cannot since you cannot communicate. Doesn't that mean it needs to allow the other VLAN to access also?
This one I think is the first method, legacy, kan?
Oh yeah.
This is legacy method. Legacy method. So FA1 should be mode access, because FA1 linked to PC10.
Okay.
Yeah, mode access. S2, F02 should be trunk. Also F2. Can you adjust your answer for item 1 and 2? Number 3, in router G01, the IP address is set to 172.16.10.254.
Can the VLAN give access to?
Yeah, the the VLAN. So PC10. Let me see. PC10 is VLAN 10. PC20 is VLAN 20. So PC10 link to S2 using access mode and port F01 S2, and the gigabit port on S2 and router should be normal lah, because you can see that it should be VLAN 10, both VLAN 10, because all the way from PC 10 to router, because this the first method, kan this one?
Alright.
Yeah, first method. This is not router on a stick, and this is also not. There is no multi-layer switch, so we can see that the two link between S2 and router means the two VLANs lah. Okay, so one of the link is for VLAN 10, one of the link is for VLAN 20. Okay. So interface F01 S2 switchport access VLAN 10, correct. Switchport mode access. Okay. Interface fast Ethernet 2 switchport access VLAN 20 switchport mode access. Right. Interface gigabit 1 switch mode trunk. Should be trunk. This is not, because should not be trunk, right? So instead of switch port mode trunk, so should be normal link kan? Should be access also kan?
Yeah.
Yeah, access mode on the switch port for gig 01's S2, so it be access mode and set to VLAN 10. Why no trunk mode? Because this is legacy. So legacy means each of the two links you can see between routers and S2 can be assigned to the top one we can assign to VLAN 20, and the bottom link between S2 and router assigned to VLAN 10. So since it's not trunk, means it's access mode. So set the that means this one wrong already. Interface gigabit 1 switch port mode trunk switch mode access mode and assign it VLAN 10. So the gig 02 also mode access VLAN 20 lah. But it says switch port mode access VLAN 10, right?
Need to
you can see here it should be VLAN 20 because it's linked to we should allow it for the VLAN 20 for PC 20.
Oh, so the 02 is with 02 lah.
We configure that way also can, as long as consistent lah your argument. So that if you say that router gig 1 and S2 gig 1 is meant for VLAN 10, then the other link should be for VLAN 2. Yeah. So let's see. Router interface gigabit 00, IP address 172.16.20. 20 and 10. But then it's wrong. Why? Why wrong? Can you notice the IP address? Can we have a 255 as the IP address at the back? Anyone? Kelvin?
Cannot.
What is 255, Kelvin or Noel or Farah? Can you see what I'm pointing at? It's 172.16.20 255. What is normally address 255? You still recall?
8 beta.
No, 255 is broadcast.
Oh.
Remember?
Oh.
/24 255 is broadcast. So broadcast you cannot assign to interface. So that's wrong already. So that should be 254, like this one. The interface gigabit 01, correctly that one, 10.254. But then again, look at the subnet mask. Is it correct? It's 172/16.
No.
Because this one is we have the third octet as 10. The other one is third octet is 20, means the third octet still belongs to network part, right?
Oh,
The first one, interface gigabit 00, is correct. The subnet mask is 255, 255, 255, means all three octets, the first three octets are network portion, right? But the wrong part is the 255, because 255 is broadcast. Your IP address should only reach up to 254, right? 0 also cannot, so must be 1 to 254. So that one is the wrong part. The second one, interface gigabit Ethernet 01. Okay, so the IP address is correct, and because it's belonging to it's allocated to VLAN 10, so yeah, we use 10 10 for VLAN. You can see here, right? For PC 10, PC 10, 172.16.10.10, right? So its gateway address should be 172.16.10. Yeah, correct. 254. Okay, because 254 is valid usable IP address. But then we notice subnet mask is only 255, 255. And that means the subnet mask is wrong, right? Because 255, 255 means slash 16, but we are looking at address which is slash 24. So that one is also wrong. 255, 255. Should be 255, 255, 255.0.
oh,
Yeah. So either you want to say that 172, okay, 172 is a slash. You can your answer can say like you can reconfigure the IP address or the network address to /16. Keep the 255 255, meaning to say the other one have to change also lah. 255 255 instead of 255 255 255. Right? Either you change to /16, or you can yeah. So 172.16 is slash class B ba kan? 172.
Yeah.
Still remember what class is 172.16?
I think it's class B.
So class B is 16. So this one is correct lah. 255 255. That means this one have an additional problem. The interface gigabit 00. Because that is /24. 255 255 255 is /24. So we have to change that subnet mask configuration to 255 255.0.0 lah. Oh. Okay. So that means if it's /16, then the 10 and 20 something wrong already, because we cannot differentiate 172.16 with 172.16. Same network address kan? You guys notice or not? See the two interface gigabit interface on the router. If we say that 172.16 is /16, right? So only 2 octets belong to network portion. The first 2 octet on both interface are the same, 172.16, 172.16. So something is wrong there. You cannot differentiate now. Okay? So that means either we change this is to /10/10 16 instead of 22 on PC2, or either we change here PC10 to /16, or we keep the PC10 /22. We adjust the interface on gigabit 01 to /22. So 255 255 252. Okay, 252 third octet means /22 following the PC10. But since here we /24 already, so this is correct lah. 255 255 255. So this is a modern network, so it's not using class A, class B, it's using the slash, the prefix. Okay, so since PC20 is /24, it matched with the address of the gateway, which is 255.255.255 is actually /24. So this part, no need to change, like this one is correct. Only the 255 changed to 254 because that one is broadcast address 255. Right, so I repeat for PC10, it's showing /22, right? If it's /22, we have to change the configuration of the IP address for the gig 01 at router. Instead of 255.255/22 means what? 16 plus 16 plus
6.
additional 6, right? Becomes 22, right? So it's if you work it out, the binary to decimal, it will be 252 lah here, right? We borrow 6 kan? So 6, we borrow 6. That means give us 16 plus 6. Okay, 6 left 2. So 11000 at the back. So it's 2. I think it's 252 lah. 255.252.0. Okay. So either way is correct, depending on your answer. If you say, all right, I want to use /16, you change PC10 to /16, then this is correct. If you remain /22 with PC10, then this is incorrect. Then you say the subnet mask should be 255.255.252.0. Is that okay?
So it means it can either change the configuration or the what logic.
Yeah, you can change the configuration on the router, or you can change the configuration on the PC, depending on which one you want to use to configure, either /16 or /22. Both depend. If you argue it, both acceptable, as long as consistent, acceptable.
Oh, see. Okay.
Okay, right. So okay, so that one also please, the 255. Please amend your answer. The 255 there cannot be, that is broadcast, so it should be 254. Okay. And then gig 02 on S2, switch port access VLAN 10. But 10 is here, right? 10 is, you can see here, interface gigabit 02 on S2 is given switch port access VLAN 10. But VLAN 10 is on this side, should be. So it should be VLAN 20. We give that to VLAN 20, right? And then this one, gigabit 01, replace the switch port mode trunk to switch port mode access. Give that gigabit 01 interface on S2, right? Switch port access VLAN 20, right?
Okay.
Okay. Right. Any more?
So this one, the configuration error actually. Yeah, I just write down the mistakes.
Yeah, just write down the mistakes and then the what it should be at the side.
Okay.
All right. So there should be 1, 2, 3, 4 problems.
Four only, then the fifth one no need.
Yeah, fifth one. I don't see any more. Can you see? So 1, 2, 3, 4. Yeah, no more.
No.
4 only can? All right, the 5th one can delete lah.
Oh, okay.
All right. Oh, how you write the configuration error is you should write like this. Instead of saying S2G1 should be accessed, because that should be in the solution part, you should repeat what the configuration error is to highlight it. So you say for item number 1, S2G01 is configured as trunk mode. Then that is the error. Right. Then the solution, then you give the correct one, switch port mode access. So same with the rest. You should repeat the error on the configuration errors column. So highlight that line is, that command is the error command. You have to let your examiner know you know what is the error. So you list out, you point out where is the error in the configuration errors column, right? And then you also know what it should be, what is the correct configuration under solutions. Okay, as long as you do that, you get the full mark. Highlight the
So
yeah, sorry, go ahead.
for this question, is it half marks for configuration errors and 2 marks for solution?
This question is, did it say how many marks?
It say 10.
Oh, 10 marks. Oh, for the item 1 is 2 plus 2. 2 marks for the configuration error, 2 marks for the solution. The rest are all 1, 1.
Oh, okay.
Okay, so 6 down here, 4 up there, so 10.
Okay.
Okay, then should you repeat 10? Okay lah, can lah 10. As long as any valid IP address for item number 4, acceptable also lah. As long as any valid IP address is used as the gateway address, because it's different network.
Because yeah, I just refer the figure only.
Yeah. 252. Yeah. Okay. So you're going to use /22 lah. 252. Okay. And okay, 254. 255, 255. Okay. All right. Okay, I think that's complete. That's correct. Oh, correct already.
Oh, okay.
So everyone following, yeah? You
Yeah.
must, you must let me know if you're not you're not following. It's very important. I can tell you from previous or last year, the test is like this. One of the question I remember, the test like this one. Check the error. No, I cannot guarantee that it's all going to come out exactly this kind of question, but since I've seen it before and its tutorial also is shown like this, so quite possible one of the question will be like this, one or more. Okay, so if you're not sure, any of you not sure, must let me know. At least I can guide or I point out. Like, so as I think you guys, since guys go through this tutorial, you will see that the way to approach this is to understand the topology. Okay, the topology is used as the one that is the correct, and then you check the configuration to achieve that topology, whether it's consistent with the topology. Right? If you see something wrong, then you know that configuration is wrong, and suggest what is the correct configuration instead. All right. So that's the technique for this and all the other checking for error, right? Okay, checking for error. Understand the topology. Take note. If the question come out like this, all the information you need should be already available in the topology. Okay, they shouldn't miss out any information. All right. Okay. Thank you for today, everyone.
Okay, thank you, sir.
Okay, sir. Thank you.
Okay. So I'll see you guys in our practical. Yeah.
Okay.
Okay.
Okay.